Welcome. We're going to look at 3.5, write and graph equations of lines. And by the way, you remember the stuttering in this, the videos that I had made before? I figured out what the problem is for that, and I have purchased a new flash drive, and that's on the way. So hopefully this is the last video that will have those little interruptions in the video. So I'm sorry about that, but help is on the way. Our objective is I can find equations of lines. So therefore our essential question is, how do I find equations of lines? We're looking at linear equations, equations that when you graph them, they create a line. This is a linear equation. And the typical form that we are accustomed to with is the slope-intercept form, which is y equals mx plus b. You can probably say that in your sleep. And you know that the m is the slope. That's why they call it the slope-intercept form, because the m is your slope. But why do they call it the slope-intercept form? Well, it's because the b is the y-intercept. So what is the y-intercept? That's the question now. Well, if you would, on your notes, go ahead and draw a Cartesian plot here, just real simple. So draw a horizontal line, that is your x-axis, and then draw a vertical line, that is your y-axis, and then just throw down a line somewhere on there. It does not have to be specific at all. If you want to pause the video and look at this picture and repeat it, that might be a wise thing to do. And notice that the intersection of your horizontal x-axis and your vertical y-axis is the origin. It's the place of all beginnings. It's where you begin counting your coordinates, is here at the origin. And the coordinates for the origin, of course, is 0, 0. So with your line, this point right here, where the line intercepts or intersects with the y-axis, this is called the y-intercept. It's where your line intercepts the y-axis. And so this letter B is the y-coordinate of that point. Since that point is on the y-axis, therefore your x-coordinate will always be 0. Going from the origin, you don't have to go to the right or to the left in order to get to the y-intercept. You just go straight up. So the x-coordinate is 0, and the y-coordinate, whatever that number is, that is going to be your b. That is your y-intercept. And then the other form that we're accustomed to is called the standard form, which is ax plus b. Now notice that's a capital B, not like the lowercase b, that's a y-intercept. Capital B really doesn't not mean anything special to us. We're just referring to whatever the coefficients are in front of these variables, and then c. So that's your standard form. Let's look now at your book at example number 1. And in this example, they give us a graph, and from this graph, they want us to write the equation of the line in slope-intercept form. So slope-intercept form. What was the form for slope-intercept form? It was, of course, the y equals mx plus b. So we need m. Here it is. We need m. And we also need b. As you remember, m is your slope. And from our last section, 3.4, you know how to calculate the slope. It's rise over run, which is the change in the y-coordinates over the change in the x-coordinates. So pick up that, or we're going to use that formula for the slope of a line in order to find, we're showing the book, aren't we? In order to find the slope of this line. Now we could pick any 2 points, but it's easiest to pick, of course, the ones that they already label, but you definitely want to pick ones that are integers, ones that where the coordinates will be integers, where it crosses the crosshairs there. So it would have been better for them to write out the equation y2 minus y1 over x2 minus x1. And it also would have been better if they, I guess they're labeling this as point 2, so you would call this x2 and this y2, and they're labeling this point over here 1, so this would be x1 and y1. So you find your slope of -2, and then from this graph, remember, what is the y-intercept? What is this b term here? That is the y-intercept. That is the place where the line intercepts the y-axis. And so we can pick that b up just from the graph, because of course the x-axis, the x-coordinate, is always 0 for the y-intercept, and the y-intercept is the y-axis, or the y-coordinate there. So 4 is our b. So now we have the m, and we also have the b, and all that we do is plug it into your equation, y equals mx plus b. So this is the equation of this line. And you are ready now to do the same thing. So here in your notes, problem number 1, write an equation of the line in the graph, or write an equation of the line in the graph at the right. So in other words, take this line and figure out what the equation is for this line. I already have given you the 2 points there. I would recommend that you label them, point 1 and point 2, and then identify each of these coordinates. This would be x1 and y1. And because this is point 2, this is be x2. Remember, x2 means it is the x-coordinate of point 2, and then y2 is 1. So then I've even written the equation for the slope here for you. But where did I get this b from? Where did I get this b equals -1 from? Well, I just picked it up from the graph. Remember again, b is your y-intercept, so the place where this line intercepts the y-axis, and each of these blocks is worth 1. So here's 0, going down 1, it would be -1. So b is -1 for this line. So now find your slope, and then plug both and then write over here, say y equals mx plus b. Make sure that you write out that slope-intercept form, and then plug in your values for b and also for m. So go ahead and pause the video and do that, if you would, please. Then example number 2, and I actually have that example from the book. I have that directly here in your notes. So let me walk you through this. Looks confusing at first, and you might even want to pause the video. I don't know, if it was me, what I would do is just put my hands down and just watch the video and listen carefully as I walk through it, and then as you understand it, then go back and write in the notes. But be real careful not just to be copying things and tune me out. What I'm explaining really is helpful to you. It's really of no use for you to copy these down just to copy them down. I could have included that in your notes, but I wanted for you to write it down so that you're thinking. So make sure that as you're writing these things down, you're thinking and you are understanding what you're writing. If you're just writing things down and you don't understand it, then you are wasting your time, unless you're going to come back and try to understand it later. So the problem here is write an equation of the line passing through the point -1, 1. So here is my graph, and -1, 1. Okay, so here's a point that this new line is going to go through that is parallel. This new line is parallel to the line with the equation y equals 2x minus 3. That's all they give to us, just this old line, or I will call it the original line. So you see what's happening here? There's an original line that they give to us, and then they give us 1 point for the new line, and they want us to find the equation for the new line that goes through that point and that is also parallel with the original line. All right, let's figure this out. So here's your original line, and it looks like, yep, it is in the slope-intercept form, so let's write y equals mx plus b underneath there. And so what is the slope for the original line? The slope is not 2x. Remember, the m is the coefficient in front of the x, so the slope is 2. So that's why I've written down here, slope of 2. But wait a second, slope is rise over run. So let's go ahead and put a 1 underneath there. There's always an invisible 1 underneath an integer. So our slope really is 2 over 1. Okay, and that is the slope of the original line, the slope of the original line. And while we're here, let's go ahead and grab the y-intercept, and the y-intercept is -3. So we can go ahead and plot. Let's remind ourselves how to plot this old line first. So you always begin at the b, begin at your y-intercept. So with a y-intercept of -3, go to the origin, and you're on the y-intercept. And now go down to -3 and plot that point. And so this is your y-intercept. Your y-intercept is 0, -3. And then let's draw the slope, or do the slope is what I've heard many students say. That's reasonable. Let's do the slope from this y-intercept, and we have a rise of 2. So I go up 2 blocks, and then I do a run of 1. I run over 1 block to the right. And how many points do I need to define a line? I only need 2, and that's what I have. I have 2 lines, or 2 points. So now I can draw a line and use a straight edge. You can just use the side of a paper if you want to. It's not necessary to use a ruler, but try to make it somewhat neat. And so here is your original line. That's your original line. So again, what they're asking us for is the equation of a new line that runs through this new point and that is parallel to the original line. Okay, well, what do I know about the new line? All I know is just 1 point. Hey, but I also know that both lines are parallel. So what does that mean? Well, you remember from 3.4 that if you have parallel lines, then they will have the same, should have underlined that, the same slope. If they're perpendicular, then they're going to be the opposite reciprocal of each other, opposite reciprocal of each other. But in this case, with our problem here, these 2 lines are parallel, so they have the same slope. So I've written in here that the new slope, because that's what we want to find, the new slope, is equal to the old slope. The old slope, as we picked up, is 2, and therefore the new slope is 2. So now we have the new slope, and we have a point. Is this point the y-intercept? Nope, it is not the y-intercept. So let's try to figure out what the y-intercept is. The way you do that, one way to do it mathematically, is to start by writing the y-intercept form. So y equals mx plus b, and then plug in what we do know. Well, I do know the slope is 2, so instead of m, I can put in 2. And I also know that this line goes through this point of -1, 1. So what I can do is, for x, I can plug in -1. So you see here that instead of x, they plugged in -1. Be careful to put parentheses around that. So what is the operation between the m and the x? Well, it's multiplication. So that's why it's important to put your parentheses around the -1, because you don't want it to be, don't want to deceive yourself into thinking, or mislead yourself into thinking that it's 2 minus 1. No, it is 2 times -1. And then the y-coordinate for that new point is 1. So instead of y, we plug in 1. But I don't know what the b is. So let me just bring down the b. But notice now that I have an equation where the only variable is b. So I can solve that equation for b. I do that simply. Well, of course, 2 times negative 2 is going to, 2 times negative 1 is going to be negative 2. Negative 2 plus 2. So what I'm doing here is to move the negative 2 to the left side. I want to add 2 to both sides. And when I do that on the right side, negative 2 plus 2 is 0. So that cancels out. And I bring down the b. And on the left-hand side, 1 plus 2 is 3. So that now is my new b. That is the new y-intercept. And so I have the new slope. I'm going to put a red circle around it. I have the new slope, which I got from the old slope because these two are parallel. And now I also have the new y-intercept. And all I have to do is plug that in to the slope-intercept form. So again, write that equation, y equals mx plus b. Get accustomed to writing that over and over again. And then plug in what you know. We know the slope is 2, and we know the y-intercept now is 3. So there is the equation of our line. And to graph this, what we can do, well, do it the same way as we did before, or let me back up a little bit and show you an easier way. Instead of doing this math, we could have done it graphically, because we did have this point, right? We had the point for the new line, and we also knew that the slope for the new line is the same as the slope for the original line, because these two lines are parallel. So all we have to do is do the slope from this new point. And we could do a rise of, a rise of 2, 1, 2, and then a run of 1. And in this case, that particular point is the y-intercept. So that is 1, 2, 3, right? So this would be 0, 3 would be the y-intercept. And so 3 is the b that we plug in down here. Okay, you are ready now to do example number 2, or problem number 2, there in your notes. And I start you off kind of easy. Write an equation of the line that passes through these 2 points. So that's not this, okay, so ignore that. Passes through these 2 points.